Hello, good afternoon. I'm pleased to speak here today on a topic that we all care deeply about, climate change, a topic that will affect our generation and our children. I've been speaking out about this topic with my grandfather, Dr. James Hansen, known worldwide for his work in climate science and his advocacy for the need to act now and mitigate the impact of global warming. Today, my peers and I want to talk with you about the clear evidence of a warming planet, the potential damage to the world we know, and the key actions working to reduce the level of warming on our planet. I'd like to start with some history to put into perspective where we are today. Even though global recognition of the potential danger to the future has led to greater awareness, the little action done has accomplished practically nothing to mitigate this danger. In June of 1992, the United Nations held an Earth Summit in Rio de Janeiro. The biggest potential of the summit was an agreement on the Climate Change Convention, which acknowledged climate change and committed state parties to reduce greenhouse gas emissions based on the scientific consensus that A, global warming was occurring, and B, it was extremely likely that human-made CO2 emissions have predominantly caused it. This became the foundation for the Kyoto Protocol, an international treaty adopted in Kyoto, Japan on December 11, 1997, over 20 years ago. While it made some progress, it has remained more of a paper agreement than one that drives action, as painfully little has occurred internationally during this period in terms of a serious response to the scope of the challenge of global warming. The 2015 Paris Agreement is just another version of the Kyoto Protocol, which the US is currently not participating in now. But as long as governments are not fulfilling these reduction goals, whether the US claims to be participating or not makes little difference in how ineffective it will be. What needs to happen is for people to be willing to take on the fundamental problem that the heads of fossil fuel companies have sided with the government for a trade of money and power. Both benefits are extremely short-term and at the highest possible cost, the habitability of our home. And even when this problem is addressed, our polarized political system gets nothing done. This means that it will take the immense pressure and effort of the public to get a solution. We cannot let them draft a protocol or agreement and wait for them to follow it, and when they don't, just make a new rule again. Since 1990, the world's CO2 emissions have increased by 51%, and 42% of the world's CO2 emissions arising from just the USA and China alone. This means that what we do here has the potential to be very effective and actually work. Here is my grandfather, James Hansen, the early warning voice, who has spoken out for the action in the early 80s. The video going on? Yeah.
And what would you do if you knew what I know? The greenhouse effect had been well understood for more than a century. British physicist John Tyndall in the 1850s made laboratory measurements of the infrared radiation, which is heat. And he showed that gases such as CO2 absorb heat, thus acting like a blanket, warming Earth's surface. I worked with other scientists to analyze Earth climate observations. In 1981, we published an article in Science magazine concluding that observed warming of 0.4 degrees Celsius in the prior century was consistent with the greenhouse effect of increasing CO2. That Earth would likely warm in the 1980s, and warming would exceed the noise level of random weather by the end of the century. We also said that the 21st century would see shifting climate zones, creation of drought-prone regions in North America and Asia, erosion of ice sheets, rising sea levels, and opening of the fabled Northwest Passage. All of these impacts have since either happened or are now well underway. That paper was reported on the front page of the New York Times and led to me testifying to Congress in the 1980s. Testimony in which I emphasized that global warming increases both extremes of the Earth's water cycle. Heat waves and droughts, on one hand, directly from the warming, but also because a warmer atmosphere holds more water vapor with its latent energy, rainfall will become in more extreme events. There will be stronger storms and greater flooding. By 15 years later, evidence of global warming was much stronger. Most of the things mentioned in our 1981 paper were facts. I had the privilege to speak twice to the President's Climate Task Force, but energy policies continued to focus on finding more fossil fuels. By then, we had 2 grandchildren, Sophie and Connor. I decided that I did not want them in the future to say, Opa understood what was happening, but he didn't make it clear. Over the next few years, I was drawn more and more into trying to communicate the urgency of a change in energy policies, while still researching the physics of climate change. Let me describe the most important conclusion from the physics. First, from Earth's energy balance, and second, from Earth's climate history. Adding CO2 to the air is like throwing another blanket on the bed. It reduces Earth's heat radiation to space, so there's a temporary energy imbalance. More energy is coming in than going out, until Earth warms up enough to again radiate to space as much energy as it absorbs from the sun. So the key quantity is Earth's energy imbalance. Is there more energy coming in than going out? If so, more warming is in the pipeline. It will occur without adding any more greenhouse gases. Now, finally, we can measure Earth's energy imbalance precisely by measuring the heat content in Earth's heat reservoirs. The biggest reservoir, the ocean, was the least well measured until more than 3,000 Argo floats were distributed around the world's ocean. These floats reveal that the upper half of the ocean is gaining heat at a substantial rate. The deep ocean is also gaining heat at a smaller rate, and energy is going into the net melting of ice all around the planet, and the land to depths of tens of meters is also warming. The total energy imbalance now is about 0.6 of a watt per square meter. That may not sound like much, but when added up over the whole world, it's enormous. It's about 20 times greater than the rate of energy use by all of humanity. It's equivalent to exploding 400,000 Hiroshima atomic bombs per day, 365 days per year. That's how much extra energy Earth is gaining each day. This imbalance, if we want to stabilize climate, means that we must reduce CO2 from 391 ppm parts per million back to 350 ppm. That is the change needed to restore energy balance and prevent further warming. Climate change deniers argue that the sun is the main cause of climate change, but the measured energy imbalance occurred during the deepest solar minimum in the record, when the sun's energy reaching Earth was least. Yet there was more energy coming in than going out. This shows that the effect of the sun's variations on climate is overwhelmed by the increasing greenhouse gases, mainly from burning fossil fuels. Now consider Earth's climate history. These curves for global temperature, atmospheric CO2, and sea level were derived from ocean cores and Antarctic ice cores, from ocean sediments and snowflakes that piled up year after year over 800,000 years, forming a 2-mile thick ice sheet. As you see, there is a high correlation between temperature, CO2, and sea level. Careful examination shows that the temperature changes slightly lead the CO2 changes by a few centuries. Climate change deniers like to use this fact to confuse and trick the public by saying, look, the temperature causes CO2 to change, not vice versa. But that lag is exactly what is expected. Small changes in Earth's orbit that occur over tens to hundreds of thousands of years alter the distribution of sunlight on Earth. When there is more sunlight at high latitudes in summer, ice sheets melt. Shrinking ice sheets make the planet darker, so it absorbs more sunlight and becomes warmer. A warmer ocean releases CO2, just as a warm Coca-Cola does, and more CO2 causes more warming. So CO2, methane, and ice sheets were feedbacks that amplified global temperature change, causing these ancient climate oscillations to be huge, even though the climate change was initiated by a very weak forcing. The important point is that these same amplifying feedbacks will occur today. The physics does not change. As Earth warms, now because of extra CO2 we put in the atmosphere, ice will melt, and CO2 and methane will be released by warming ocean and melting permafrost. While we can't say exactly how fast these amplifying feedbacks will occur, it is certain they will occur unless we stop the warming. There is evidence that feedbacks are already beginning. Precise measurements by GRACE, the gravity satellite, reveal that both Greenland and Antarctica are now losing mass, several hundred cubic kilometers per year, and the rate has accelerated since the measurements began 9 years ago. Methane is also beginning to escape from the permafrost. What sea level rise can we look forward to? The last time CO2 was 390 ppm, today's value, sea level was higher by at least 15 meters, 50 feet. Where you're sitting now would be underwater. Most estimates are that this century we will get at least 1 meter. I think it will be more if we keep burning fossil fuels, perhaps even 5 meters, which is 18 feet. This century or shortly thereafter. The important point is that we will have started a process that is out of humanity's control. Ice sheets would continue to disintegrate for centuries. There would be no stable shoreline. The economic consequences are almost unthinkable. Hundreds of New Orleans-like devastations around the world. What may be more reprehensible if climate denial continues is extermination of species. The monarch butterfly could be one of the 20 to 50% of all species that the Intergovernmental Panel on Climate Change estimates will be ticketed for extinction by the end of the century if we stay on business-as-usual fossil fuel use. Global warming is already affecting people. The Texas, Oklahoma, Mexico heat wave and drought last year, Moscow the year before, and Europe in 2003 were all exceptional events, more than 3 standard deviations outside the norm. 50 years ago, such anomalies covered only 2 to 0.3% of the land area. In recent years, because of global warming, they now cover about 10%, an increase by a factor of 25 to 50. So we can say with a high degree of confidence that the severe Texas and Moscow heat waves were not natural, they were caused by global warming. An important impact, if global warming continues, will be on the breadbasket of our nation and the world, the Midwest and Great Plains, which are expected to become prone to extreme droughts, worse than the Dust Bowl, within just a few decades, if we let global warming continue. How did I get dragged deeper and deeper into an attempt to communicate, giving talks in 10 countries, getting arrested, burning up the vacation time that I had accumulated over 30 years? More grandchildren helped me along. Jake is a super positive, enthusiastic boy. Here at age 2.5 years, he thinks he can protect his 2.5-day-old little sister. It would be immoral to leave these young people with a climate system spiraling out of control. Now, the tragedy about climate change is that we can solve it with a simple, honest approach of a gradually rising carbon fee. collected from fossil fuel companies and distributed 100% electronically every month to all legal residents on a per capita basis, with the government not keeping one dime. Most people would get more in the monthly dividend than they pay in increased prices. This fee and dividend would stimulate the economy and innovations, creating millions of jobs. It is the principal requirement for moving us rapidly to a clean energy future. Several top economists are co-authors on this proposition. Jim DePeso of Republicans for Environmental Protection describes it thusly: transparent, market-based, does not enlarge government, leaves energy decisions to individual choices, sounds like a conservative climate plan. But instead of placing a rising fee on carbon emissions to make fossil fuels pay their true cost to society, our governments are forcing the public to subsidize fossil fuels by $400 to $500 billion per year worldwide, thus encouraging extraction of every fossil fuel: mountaintop removal, longwall mining, fracking, tar sands, tar shale, deep ocean, Arctic drilling. This path, if continued, guarantees that we will pass tipping points, leading to ice sheet disintegration that will accelerate out of control of future generations. A large fraction of species will be committed to extinction, and increasing intensity of droughts and floods will severely impact breadbaskets of the world, causing massive famines and economic decline. Imagine a giant asteroid on a direct collision course with Earth. That is the equivalent of what we face now. Yet we dither, taking no action to divert the asteroid, even though the longer we wait, the more difficult and expensive it becomes. If we'd started in 2005, it would have required emission reductions of 3% per year to restore planetary energy balance and stabilize climate this century. If we start next year, it is 6% per year. If we wait 10 years, it is 15% per year. Extremely difficult and expensive, perhaps impossible. But we aren't even starting. So now you know what I know that is moving me to sound this alarm. Clearly, I haven't got this message across. The science is clear. I need your help to communicate the gravity and the urgency of this situation and its solutions more effectively. We owe it to our children and grandchildren. Thank you.
Good afternoon, everyone. My name is Nicole Crescimanno, and I am the co-leader of the New York City chapter of Citizens Climate Lobby. I'm just going to talk a little bit about sea level rise. Sea level rise is one of the greatest threats that the millennial generation faces, as more than half of the world's largest cities are on coastlines. Melting ice sheets in Greenland and Antarctica are speeding up the already fast pace of sea level rise. At this rate, the world's oceans will be an average of at least 2 feet higher by the end of the century. Even small changes in sea level rise can lead to flooding and erosion. 2 feet of sea level rise by the end of the century would have devastating consequences and effects on coastal cities like Miami and New Orleans. One study estimates that storm surges, floods, and hurricanes could be costing the world $1 trillion a year by 2050. And another puts it at $100,000 billion a year by 2100. The cost of not acting is so large. Imagine what happens if these cities are partially submerged. Many would become dysfunctional. Think about how many climate refugees there'd be from places like Bangladesh, Alaska. Our systems of government would become unmanageable and ungovernable. Thank you.
Hello, everyone. My name is Andrew Herrera, and I am a senior environmental studies major at Ramapo College of New Jersey. And I'm just going to talk briefly about the extreme weather threats that are posed by climate change, some of which will be facing us in the future as our generation grows older, but some of which also face us right now. So firstly, to speak on hurricanes, as the sea surface temperatures warm in the Atlantic Ocean and in the Caribbean, they'll be able to sustain stronger storms that can travel farther. And so according to scientists' studies of climate models, even though we'll see less hurricanes on average, we will see many more Category 4 and 5 storms. So stronger storms, such as Hurricane Maria last year, will be more commonplace and pose much greater threats to us. And our last hurricane season, just to add, was 10 hurricanes versus an average between 1981 and 2010 of 6. So we're already seeing more frequent and more powerful storms. And then to speak on heavy rains and deluges, the deluge that we saw happen with Hurricane Harvey is also likely to become more common because as air temperatures rise, they'll be able to hold more water before they eventually rain it all down. And we saw with Hurricane Harvey how the rain stayed and pounded the city for days before it finally subsided. But according to current climate models, an event like that, which around now is about a 1 in 500 chance of happening, 1 in 500 years, will rise to about a 1 in 20-year chance of occurrence by the end of the 21st century. And while Harvey was happening in the United States, India, Bangladesh, and Nepal were flooded by a torrential monsoon season which killed over 1,200 people. It was an unprecedented rainstorm. And now I'm going to speak about droughts. And droughts will also become more severe in places. So while some areas will receive heavier rainfalls, other places, like the western United States, will see worse droughts. And that's because as temperatures warm, areas such as California, Washington, and Oregon, which are dependent on snowpack for their water sources, will lose that snow to more evaporation as the surface of the ground grows hotter. And that water will be lost. I think we all recall California's drought, which lasted up until the end of 2016. But in the meantime, while their drought has subsided, Cape Town in South Africa, as I'm sure many of you have heard, is now currently facing day 0, a day when it will run out of water because of constant evaporation of its main water reservoir due to 2 of its worst droughts on record, which happened in 2014 and 2015. They've instituted some really excellent water-saving measures, and they've managed to push that day back to July 9th of this year. And next, I'm going to speak about wildfires, which are, of course, connected to droughts. So as I was saying, in the western United States, they depend on snowpack and snow melt from the mountain caps for much of their fresh water. But with temperatures warming and winters becoming hotter, that snow is more likely to melt earlier in the year, when in reality it needs to melt in the summer, because by the time the summer rolls around, which is already a dry season, the grass and the brush and the leaf litter on the ground will be much drier, and it will be much easier for fires to spread and continue to burn. And for the clearest example, I would just point back to the Thomas Fire, which burned for over a month from December 4th of last year to January 12th of this year when it was finally contained. That fire was able to burn an area that's about the size of New York City. Thank you.
Sorry about that. Hi, my name is Anna. I'm going to speak today about heat and its effect on health. Okay, so heat waves, also known as heat or hot weather that lasts for several days, is a pervasive natural hazard that exacts a heavy toll on human systems, such as health, livelihood, and infrastructure. They also burden health and emergency services and strain physical infrastructure like energy, water, and transport. Heat waves are an emerging health problem that are only going to increase in the future. If you think of the last few years, we've been experiencing a lot of hot weather, especially over our summer periods, but more even so, even during our spring and into fall. Heat waves can cause severe dehydration and acute cerebrovascular accidents and further aggravate chronic pulmonary conditions, cardiac illness, and psychiatric illness. By 2100, with a rise of 12 degrees Fahrenheit, the Earth would be too warm in some areas to be cooled with air conditioning. With a 21-degree rise, it would put half the world's population in uninhabitable environments. Climate change is affecting our air quality, increasing concentration of ozone, fine particles, and dust. New Delhi schools had to close for a short period because of smog. It affects driving, it affects transportation, and it affects everyday lives. Increase in incidence of hospital admissions when triggered by temperature change. So people are more likely to go to the hospital and need to go to the hospital when extreme weather patterns are happening. Specific pathogens may increase with a temperature rise, which can lead to inadequate hygiene, improper handling of food, and lack of hand washing, which can lead and has led to epidemics of different sorts connected to infectious diseases. An increase in the incidence of waterborne diseases is caused by the frequency of severe rainfall, and they have very devastating impacts on communities that have no infrastructure to deal with such events. The variety of weather impacts have on the sociological being have been very problematically in a lot of people with mental disorders. People with mental disorders are very impacted by the environment, and the environment, of course, impacts us, and we impact our environment. So heat waves and the general aspect of all the things that have been happening recently have caused a lot of change in our environment, and they're only going to increase in the future. Thank you.
Hello everyone, my name is Ariana Freitag and I'm a second-year electrical engineer at the Cooper Union. I'm going to be speaking about the impact global warming is having on our environment and our ecosystems. Global warming is destroying the environment that sustains all sorts of life. As we are producing tons of CO2, we are rapidly cutting down trees and forests that act as carbon sinks, meaning that they take the CO2 that's in the air and convert it to oxygen through photosynthesis. Instead of preserving these forests to keep the natural process of cleaning our air, they are being cleared to get timber for mass production and to open land use for factory farming and livestock production, another source of greenhouse emissions. The clearing of the world's forests stops the natural process of removing CO2 from the atmosphere, as well as opening the door for exploitative industries to just contribute even more to the rising climate change through greenhouse gas emissions. Forests do not only convert CO2 to oxygen, there are other many benefits they provide, such as preventing erosion, contributing to the water cycle by trapping water in the soil, and sustaining diverse ecosystems like in the Amazon rainforest. Currently, forests cover about 30% of the Earth's land, but if the rate of deforestation continues, which is at about 46 to 58,000 square miles of forest being cut down each year, in about 100 years, our rainforests as we know them will be gone. A primary method of clearing land, which is burning, releases about 1.5 billion tons of CO2 each year, and entire ecosystems are having their climate shift, with there now being 4% more water in the atmosphere than there was previously before in the Industrial Revolution. The clearing of our forests is removing this vital carbon sink and is just making the development of global warming happen at a much faster rate. Humans are not the only ones affected by the change in climate, there's extinction that is occurring for many different species. 7% of mammals and 4% of birds are threatened currently due to climate change, and there are about 450 species that are facing local extinction, meaning that within like their local ecosystems, populations are starting to be completely wiped out. So it's becoming a really big issue with a lot of species like the white rhino, where they're now mostly living only in captivity. This is really concerning to scientists, especially looking at the tropics, where the most biodiversity of ecosystems occurs. And many scientists are calling this the sixth mass extinction, with in the next 50 years or so, they're predicting that 30 to 50% of species will be threatened. Another impact on the environment is ocean acidification. Ocean acidification describes a process of the ocean absorbing CO2, which is then converted to carbonic acid and is no longer preserving the balance of pH within the oceans, which is affecting many ecosystems. The oceans are currently absorbing about 25% of all man-produced CO2, and since the early 1900s, our oceans have become 30% more acidic. This has caused many ecosystems within the ocean to have mass death. So the Great Barrier Reef in Australia is experiencing something called coral bleaching, which is when the corals they're dying completely. They're becoming bleached, they're losing their colors because the algae on the coral is dying, and then the ecosystems that rely on the algae and the coral are also being completely wiped out. So coral reefs protect the coast from erosion, as well as they are a main factor of tourism and industry within Australia. Coral reefs produce about $375 billion each year just through fishing and tourism industry. So the ecosystems are dying, as well as the people that rely on these ecosystems for their livelihood are no longer having that access. Global warming is changing our environment as we know it and is causing many ecosystems to no longer support us. If we do not change our ways, there will be mass extinction of many species, and humans could very well be one of those species. Thank you.
Hi everyone, my name is Sophie Schneider. I'm a second-year mechanical engineering student at the Cooper Union. I'm here to talk about food security. So the dramatically changing climate is set to have irreversible effects on the state of food security across the world. Food insecurity exists when a certain group of individuals does not have physical or economic access to a sufficient supply of nutritious food. With the drastic effects of global warming, the 4 dimensions of food security, namely food availability, access to food, stability of food supply, and food utilization, are under immediate threat. Short-term fluctuations in food production in semi-arid and sub-humid areas will become more severe and more frequent as a result of the changing climate. In semi-arid areas, droughts can dramatically reduce crop yields and livestock numbers. Most of this land is in sub-Saharan Africa and parts of South Asia, meaning that the poorest regions with the highest levels of chronic undernourishment will also be exposed to the highest degree of instability in food production. Less is known about the role of climate change for food stability and utilization, at least in quantitative terms, but it is likely that differences in socioeconomic development paths will also be the crucial determinant for food utilization in the long run, and that they will be decisive for the ability to cope with problems of food instability. Climate change will also affect the ability of individuals to use food effectively by altering the conditions for food safety and the changing disease pressure from water and foodborne diseases. The main concern about climate change and food security is that the changing climatic conditions will initiate a vicious cycle where infectious disease causes or compounds with hunger, which in turn makes the affected populations much more susceptible to infectious disease. The result can be a substantial decline in labor productivity and an increase in poverty and mortality. All manifestations of climate change, including drought, higher temperatures, and heavy rainfalls, have an impact on the disease pressure, and there is growing evidence that these changes affect food safety and food security. Greater food insecurity could even pose a security threat as competition intensifies for water and arable land. The IPCC report warns about an increase in risks of violent conflicts in the form of civil war and intergroup violence. The decade-long armed conflict in Sudan, the ongoing civil war in Syria, and unrest in Egypt are all examples of how severe drought, internal migration, and economic hardship can lead to devastating instability. Finally, all quantitative assessments we reviewed showed that the first decades of the 21st century are expected to see low impacts of climate change, but also a lower overall income and still a higher dependence on agriculture. During these first few decades, the biophysical changes as such will be less pronounced, but climate change will significantly affect those still more dependent on agriculture and those who have lower overall incomes. In contrast, the second half of the century is expected to bring more severe biophysical impacts, but also a greater ability to cope with them. In order to achieve food security, all four components must be achieved and maintained simultaneously. And while each component of food insecurity is highly sensitive to climate change, it is essential to discuss them as a whole in order to effectively cope with the undeniable changes to our climate and our food supply. Thank you.
Hi folks, my name is Anastasia Caulfield. I'm an international studies major and human rights minor at Ramapo College. So I'm here to talk to you all about climate refugees and I suppose the effect that climate has on people all over the world. So first I'm going to just read the definition of a refugee according to the 1951 Convention on the Status of Refugees. So it states that a refugee is a person owing to well-founded fear of being persecuted to reasons of race, religion, nationality, membership of a particular group, or political opinion, outside a country, and is unable or owing to such fear is unwilling to avail himself of the protection, of that country. So unwilling to return to a country defines somebody as a refugee. But climate refugees are not enmeshed into that category of people that need help and assistance. This is the world that we could be living in. More than half of us could be in danger of food insecurity and a place to live. A place to work. And so I think that it's important to define climate refugees as people that are asylum seekers. There's 25 million people that are refugees, that are refugees that are seeking asylum, but 65 million people are displaced from their homes. So 65 million people are around and could be subjected to foodborne illnesses, death, and death from just not having a place and owning a sense of identity. That is also dangerous for humanity. I think that's important to be an ally. And so I thought that it was interesting that a paper featured in the New York Times states that weather shocks are compelling to people to seek asylum in the European Union. Applications for asylum have increased along with hotter than normal temperatures. Weather shocks between the year 2000 and 2014 on agricultural regions in 103 countries around the globe have been directly influenced by emigration. I really hope that we take time to take the environment and the place that we live in seriously. I think that my peers have covered climate change in a respectable manner, and I appreciate you all being here. Thank you.
Hi, everyone. So I just want to talk a little bit more about Citizens Climate Lobby and the carbon fee and dividend policy that Dr. Hansen briefly touched on in the TED Talk we just saw before our panel started. So